clock system you've got there, checking everything, your diagnostic setting.
Yeah, it's useful when I started having issues. Apparently 16 gigs of RAM was not enough to do CAD and teach on online. So it was useful to tell me that. All right, it's the recording. For the people who've missed this, we've so far just started a new circuit. I've put a battery in place, a single 1.5 battery, hooked an LED up to it, turned it on, it lit up just barely. I then changed the battery to a 2 battery version. I then ran it without a resistor, and the LED popped. I've now inserted the resistor, and you're caught up. So if I start simulation now, the LED should light nice and happily. Now, this is a 1K resistor, but that's fine for what we're doing. That shouldn't cause any, that's a good value.
Now, does the TinkerCAD take into consideration like the different values for different colors?
I'm not sure if it does, but we can change the resistance to, so a blue.
Looks like it does.
Okay.
If you just change the number, the colors change.
Yep.
Just add a 0 to it, you'll see it change.
Yeah.
To orange.
If you change the color in the drop-down menu, I don't know if it handles the fact that the resistance are different. I don't really want to get too much into that because it doesn't, for this level of stuff, it doesn't really matter. But we can talk about, exactly V equals IR stuff.
Oh yeah, no, that's fine. I'm just curious about the program basics and how it thought.
Yeah. I know I can get away with LEDs with just put with the RGB LED running the same resistance values to all 3 of them, and it works okay. So, all right. So if we keep amping up the batteries, so let's go up to a 4 battery circuit. This is now a 6 volt circuit. If I simulate the light, it's going to be very bright, but that resistor is still enough to keep it from burning out. So this is a very basic circuit, but this stuff is kind of boring. We could add a bunch of LEDs and see how they work. And I deal with my kids so I can get used to the program. But I would like to move on to something a little more powerful because it will help us for the rest of the stuff we're going to be doing tonight. So I'm going to take and I'm going to hit Control. I'm going to click and delete all my stuff. And we are going to go and we're going to go to Components and we're going to go to Starter. We're going to go to Starters. And I'm going to go to Arduino, and I'm going to increase my font, my screen size. Hold on. Control plus.
Components, Arduino. Okay.
Okay. Starters, and we're going to go to Arduino Starters. And I like the Breadboard starter for most of my projects. Now, our TinkerCAD can be slow. Don't drag more than one, as I've done here, because it will just keep generating them. And the more you drop, the slower it gets.
The perfect example of what not to do.
It was actually intentional because people don't see the problem. I've had kids get 6 or 7 Arduinos and bring their Chromebooks to a halt, basically, and have to reload the page. Like, close out and start a new circuit.
I actually have one of these, but I think I got that thing back in, like, 2011 or 2012.
The Arduino Uno's been around since, I think, 2003 or 4. I've been using them since, 9 years of teaching, so 2011, I've been teaching with them. And the Arduino Uno, if you need a single piece of hardware to learn some basic electronics, I would buy a cheap kit on Amazon with an Uno that costs somewhere around 35, 40 bucks, has some components. It's very hard to kill an Arduino Uno. I've had one kid kill one electrically. I've had him kill broken mechanically, but electrically, I've only had one die, and it was doing terrible things. He put 12 volts in. He put 12 volts in through one of the inputs and blew up the chip.
Nice.
I was less than pleased because he asked and I said don't, and then he did it, and then it blew up. And I'm like, really? And even that cost me $3. I bought a new just the chip here.
Yeah, I was gonna say you
and
can just put a new
stuffed it
chip
in.
in, right? Yeah.
Yep. This is why I love these. I like other microcontrollers better for a lot of reasons, but with kids and basic learning, it's real hard to screw up an Arduino bad enough that it breaks it.
I'm bummed. I can't find it.
A
All
quick question for you.
Of course.
Just because I was able to get this up, how do I connect the wires between the Arduino? You probably did it when I wasn't looking.
Oh, I didn't actually. What I did was I went to
Yeah.
Starters.
Yeah.
I went to Arduino and I grabbed the
Yeah.
Arduino breadboard all at once.
Oh, you grabbed them both at the same time.
Yeah, it's a starter that's all wired up for me.
Oh, okay. Well, if that's the case, I'm just going to delete them and do that.
That's the way I would do it. It's much
All right.
easier, and the wiring's nice and pretty. And you know, I have to go switch and make them all like nice and pretty looking, and it does it for me.
Yeah. All righty.
So we're gonna start off building very similar stuff to what we built before, just to see how this works. I'm gonna go back to basic components. And is everyone familiar with the breadboard or prototype board?
Mm-hmm.
Is there anyone not? Because I can easily go over and explain how they work.
Oh, one quick question. How do I grab both things? I'm able to grab the Arduino or the breadboard, but not both. Do I have to hit Control or Shift?
Nope. So hold on one second. If you can hit the present button if you mouse over, go back to the Google Meet tab, and if you bring your mouse over, there's a white bar that says you're presenting, that says present on the bottom right hand corner. Click on that and share your screen so I can take a look and I'll tell you exactly what's going on.
All right. Let's see. Here we go.
That's fine. This is my common teaching method for my kids, and it works really well because I can quickly see what people are doing wrong and walk them through.
Okay, I see where it says you're presenting.
Yep.
So.
And you have to click the share. You have to click it'll have a little pop up that has your screen. It says like share screen.
Okay, present your entire screen. Okay, this will be interesting because I'm using two screens right now, one for you and one for this.
That's fine.
In fact, actually, okay, here we go. So I'm going to share.
You'll ask your screen.
All right, so I'm sharing.
Yep.
I will be sharing this guy here.
Yep, we're good. So where it says components, basic. Move your mouse down a little bit to where it says. Where's your mouse?
Okay, let me get it from my big screen here. Okay, so
Okay. Move your mouse up to where it says components, basic. Click the drop down.
Yep.
Now go to starters, Arduino.
Okay, there we go.
Click on that. Now there's the Arduino breadboard. Grab that.
Okay. Actually, there's already one connected. Yeah.
Oh,
I'll tell you what. Let me first kill off. Okay, there we go. I'm there. So
perfect. All right, and then you can stop sharing your screen because it will be slower.
Yep. Okay, so I stopped sharing. Thank you.
Perfect. I said it's easier than trying to talk you through the problem, as I can see it, and we can use it real quick. All right. So our breadboard has a couple of different sections. So on the top and bottom edges are what are called the bus lines. Now they're labeled plus and minus, but that's just paint on a piece of plastic. But this is already wired up properly. So this plus is hooked up. If you follow the wire, this whole line is connected down over to the Arduino where it says 5 volt. And the minus is hooked over down to the ground. And then this wire jumps the connection from here, this plus, all the way over to make all these. So every single pin here and here are 5 volts. And every pin here and here is ground, which is the equivalent of positive and negative on our battery. Except this is sort of like just a little more than 3 batteries hooked together. And then on our breadboard, we have our columns, or the rows rather. And the rows are hooked together. All these are connected. Then there's a break at the gutter, and then these are all connected. If you mouse over, you can actually see how they're lit up to show you what's connected to what. We're going to start off by taking and plugging and grabbing an LED and just dragging him over to the breadboard and dropping him anywhere on the breadboard. It doesn't matter where. Just connect it to, just as long as not in the bus lines, anywhere on the rows.
whole layout suddenly just seemed to change.
Oh, well, Google Meet.
Yeah.
It does that. If more people join, if it can go to the presenter mode. I'm going to resume presenting. It stopped focusing me because we had 2 presenters. That's all.
There we go.
I fixed it. Sorry.
Thank you.
Yep.
That's all.
Yeah, if you catch something confusing, please, you're presenting stuff. This is the hard part teaching remotely, is I can't look at your stuff, and so I'm kind of flying blind as far as knowing what your guys are having trouble with or doing stuff. Or if I move too fast, don't be afraid to stop and slow me down, or speed up if need be. So I'm gonna now grab a resistor. I'm gonna hook a resistor from the power bus to the same row as the anode of my LED. So I just dropped him from the plus line to the anode, the same row as the anode of my LED. I don't have to draw a wire here because they're already connected. Because if you look, the green is all there. You're probably not on crappy Chromebooks, so I don't have to worry about like screens being too small.
Yeah, no.
I'm then going to run a wire from the cathode of my LED to the ground. I'm also going to change that wire to be a black wire because I want to remember that it's negative. And negative is black because it's bad and cats are jerks and whatnot. If we start simulating now, the LED should light up just fine. You'll also notice that on the Arduino, there's a light blinking. Yes, Bill, what's up?
Yeah. Can't see how to do a wire. How to make it wire.
All you have to do is click on one of the dots.
Okay.
And drag. Click and drag. But you have to not be simulating. So stop simulation, click, and drag.
All right. So click and drag, and then release.
Release when you want to stop, or
double click, I guess.
Yeah. Yes, you can click, or you can double click to make a. You can click to make a corner, and then.
Okay.
Yep. And just as long as it terminates, and then if you start simulation, the light to go on. And we should all be happy. If your light doesn't go on, please let me know because we'll make sure these things get fixed now, not later when we get more complicated.
Yeah, it helps if you plug it into the right rail.
Yep, that's this is. It's one of those things where it feels basic to start here, but if I don't diagnose these problems now, everything else gets more complicated very quickly, and it gets really annoying.
Yep.
So we have our LED. Everything's happy. I'm going to stop simulating. And I'm going to delete the ground wire. I'm actually going to move my resistor over to the... Oh, no. I'm going to move my resistor over to the negative because I actually want to drive the positive side, but we'll take care of that in a second. So I am moving my resistor over and up one to make sure it's connected the right way because LEDs are polar. The net cathode has to go negative or else it won't work. I'm now going to run a wire from the anode side of my LED to pin 8. And you can make it prettier than that, but I'm going to say that. And I'll make this wire a blue wire just because I like color blue. So instead of driving this LED just by hooking it into power, we're going to control this LED with the actual Arduino. Now, I like to use the C programming on it, instead of block code. Is that going to be okay with everyone? Does anyone never programmed anything at all? That's. Oh, I know
you've done them.
Yeah.
How about this? A TRS-80.
Oh man,
that's fine. This is actually
throwing it back.
That's honestly the programming on the Arduino is so simple. It's a good place to start. The advantage is that this will carry over if you actually buy an Arduino. Everything we learn here will work perfectly. If we use the block code, you'll have to learn something new if you get an actual Arduino. So I'm going to go with the coding on the standard code. So we're now going to.
I actually have I did. It's funny you mentioned it. I actually have right here the starter kit, the 2560 Arduino starter kit. So
yeah, so that's perfect.
So it's perfect.
Yep.
Okay.
So now I'm gonna open. Yep.
Chris, I'm going to make a confession at the extreme opposite end of that. I understand programming pretty well. I've never built a breadboard before, but I wanted to do this more to get a top-level understanding of further programming we can do in the makerspace.
Perfect.
And now to get the kids in.
Excellent. That's again, I'm happy to help however you guys want to learn. If there's stuff you want to go more into, just to ask. That's again, this is really for you guys. So so that's great. So that means the programming shouldn't be a big deal. All right, so we're gonna go open the code panel, and I'm gonna switch from blocks to text because the blocks are annoying, and every time I try to use the blocks, they fight me.
Blocks to text. Okay.
Is my font size good for everyone?
That's fine by me.
Works for me.
Okay, I'm used to 13-inch Chromebooks, and then I have to make it like gigantic so I can actually see it. So.
Okay, yeah, I had a little issue here. Oh, son of a gun.
Of course, that's fine, Bill.
Yeah, it's my once in a while my mouse ends up on the other screen and I have to drag it back here.
Yep.
Come on. All right, there you go. First of all, now if you want to move a wire, can you just you can't. You have to kind of delete it if you don't.
I typically delete it and redraw it. You can technically rearrange them, and you can do this. You can like make base bendy wires, and then you can adjust the path. And if you grab the green point, you can move that connector. But 9 times out of 10, I just delete the wire and just redraw it. I find it more reliable and easier.
All right, so I got the wire back there. I guess the issue I had was blue. Okay, how do I get to the code thing?
If you go to the top of your screen,
there's
a nice big button that says code.
Okay, just hit it.
And then you're going to go to drop down and you're going to select text.
Okay, blocks to text. Yeah.
I'll make wire blue just like I did before. All
right, I'm there. Sorry about that. I'm here now.
No worries. It's easier to catch everyone at the same time. All right. So right now, we're going to just force it to work, and then we're going to make this program better and better. So we're just going to force this to work by changing all the 13s to 8, and I'll explain more in a moment. So we're just going to take that and change that. So every 13 becomes 8. And why 8? Because that's the wire I hooked it into on the Arduino. If I plugged it into 5 or 3, I'd plug in 5 or 3 or whatever number this is connected to. And when you're ready, you can start simulation, and we should have a blinking light.
So now you want the okay.
Oops. Okay, I forgot the one down here.
It's okay.
Now, was there one where I could when I changed it to 8? Was there a way that you could change them all at the same time, or did you have to go all through all 3 of them? In the lines.
I had to do each one. We're gonna improve the code very quickly to make it not that a problem. But I'm starting out basic just to get people comfortable, and then we'll quickly make the code better.
Okay.
I just want to prove that everything works before I move forward because baby steps are best.
All right. Yeah, I did the simulation. Mine's not blinking, so.
Okay. Do you want to share your screen? I'll take a look.
All right. Hang on a second. Got to get up here again. All right. Here we go. Let's see. Click. Share now. Screen 1. Okay. Now you get the mouse back down here.
Oh, I see it right away.
Okay.
So click over near click on, let's hide the code panel.
All right, first I got to get the mouse down here. This is really annoying. I apologize.
That's okay.
Come on.
So stop the simulation once it's back over where it needs to be.
All right. Get on. Come on. This is so annoying. I feel like an idiot.
It's all right. I have two screens, but I just have my mouse sensitivity like really high, so that.
Yeah, I don't know. It was working before as far as me being able to move the mouse. Oh, here we go. I finally got it here.
Yeah.
Jesus.
All right.
All right. So
cool.
stop simulation, you said.
Yep, and then hide the code panel.
Can I get rid of this thing where it says lesson completed? This whole thing.
Yes, press done. I don't know why that.
I did press done, and it still was there.
Oh, that's annoying.
Yeah.
Because it has the. Okay. We'll take care of that in a second.
Okay. All right. So, anyways, yep. So back to.
Just hide the code panel. So click on the code panel. Click on code up top.
Yeah. Hang on.
It's okay.
All right, I'm really feeling like an old man now. I can't get this mouse to go to the right screen. Come on.
Monitors aren't reversed, are they? So instead of going right, you need to go left.
Okay, here we go. Yeah, well, I think that's it. I had to go left off of the top one to get down to this one.
Mm-hmm.
Oh,
All
okay.
right, so anyways, so finally here. All right, so hit the code button.
Yep. And you'll notice, look at your wire that's going from 8. He's not in the same column as the LED. He's actually in the negative rail.
Okay, the negative rail. Oh, geez, I see.
Yep, that's okay.
And
yep.
Boom.
Up a little higher. Up, bring him up a little higher. Up.
Yep.
Just, yep. Up more.
There we go.
There. Let's go.
All right, so
Now
once you see that. All right,
simulation.
now. Yep.
Press the start button. Yep.
There we go.
It's blinking. Good. Perfect.
All righty. Apologize,
Okay.
everybody, for being so stupid here.
No worries.
Now, can you take? Yeah, you're going to take back control. Okay, good.
Yep, I am.
All right, great. Thank you.
Okay. So it's easy to do when you're just learning. No big deals. So what we're going to do is I'm going to stop simulation, and we're going to make this a little more powerful. But copying and pasting numbers is really annoying. So what we're going to do is we're going to create a variable to keep track of what pin we are. And that is going to be a numeric variable, in this case, an integer. And we're going to use int, following counts. And I'm going to call this variable LEDPin. I'm going to set that equal to 8. Every line in C has to end with a semicolon, so just make sure you do that. I will forget regularly because I often program in Python, and that doesn't require it. So I will make semicolon errors regularly. Now I'm going to copy where it says LEDPin, and we're going to start going through the code to talk about what everything is doing. So every Arduino program has 2 functions at minimum. It has a setup function and a loop function. The setup runs on boot right after the bootloader loads. So this will set everything up for us, and it'll do it once. And then we have a loop method that runs until the Arduino loses power. And once it gains power again, it'll run setup again, and then it'll run loop forever. So pinMode tells the Arduino what you want to do with the pins. The Arduino is really powerful in that your pins can be assigned inputs or outputs. Some microcontrollers, you don't have that flexibility. So we need to tell it what the pin is. So we want to change this 8 to LED pin. And I'm just copy and pasted this name so I can hit Control V and replace it. An LED pin is an output.
So integer and just basically replacing the 8 with the LED pin.
Yep.
I see what you're doing now. All right.
And then we have our loop function. And our loop function writes the value, writes to the pin 8, which we're going to replace with LED pin, to high, which is going to turn the light on. Basically apply 5 volts to that pin. It's then going to wait 1,000 milliseconds, which is 1 second. And then it's going to write, and we want to tell it to the LED pin low, and then wait 1,000 milliseconds. And let's make this faster. I'm going to make it 100 milliseconds so it blinks faster. Once that's done, I can start the simulation, and the light should blink really quick.
Very quick.
Now, some people, it's not going to blink nearly as fast. And that's because our simulator runs in simulator time. This is actually simulating the entire Arduino. It's kind of crazy. So on a Chromebook, it runs really slow. Like something like 5 or 6 to 1. I've seen it as low as like 10 or 15 to 1. Or it takes like 10 seconds to get 1 second of processor time of Arduino time. So if you lost this clock, my clock seems to be pretty much in sync right now, but it depends on the Arduino service. It depends on a bunch of different things. So if this clock is running slower, that's going to change how your circuit behaves. All right.
Oh, I see what you mean. So that clock is based off of the processing power of whatever it is you're looking at.
It's based on the processing power of the thing you're looking at. It's based on the processing power of how overwhelmed TinkerCAD is. So when I'm in the middle of school day, TinkerCAD gets hammered because it's not they're a really powerful site for teaching stuff. You know, right. This let my robotics 2 class go on without losing any time whatsoever. Really, we basically just picked up what we were doing and moved online. Within a day, we were back to where we were in class.
No kidding.
Which is really, really cool.
Yeah.
But in the morning, it can be very slow, and as a result, there. It also depends on how complicated your circuit is on your Arduino, the code in your Arduino is. If you have more complicated code, it slows the simulation down. So I just want to demonstrate now that we've made this much better. I'm going to take my wire. I'm going to move it over to pin 7. Just do it. Now to change our code, I'll change it to 7 once, and all the code's going to work again automatically.
I want to move it. Oh, you got to click first. Okay.
Yeah, you click first, and then grab the endpoint, and you can move it.
Okay. All right. So you had to just... Oh, all right. So all you have to do is just change 1.
Mm-hmm.
So that integer is now... Okay. Let's see. Still blinking.
Yep. We're going to actually move him over to a pin that has this little negative sign. It looks like a negative, but it's actually a tilde. And we're just going to grab... I'm going to go to pin 6. Again, changing that pin is now trivial because we made it a variable. And everything's great.
Still have to physically change that pin, though.
You still have to move it over. You have to change that one pin, but it's not. But it's easier than changing it 3 times. You change it once.
Right, but I mean, in the code, you still have to actually physically change that to a 6.
Exactly, but it's still a lot nicer than Control C, Control V one time.
Yep. No, that's cool.
All right. So the difference between the pins without the tilde and the pins with the tilde is that the pins with tilde support what's called Pwm mode. And Pwm mode is what's called also known as pulse width modulation. And what it is sort of like you can't really turn things on and off like halfway on Arduino, but if you blink the lights real quick, it's sort of like being on half the time. When we flashed that light at 100 milliseconds, it almost ran like a slightly dimmer light. And if we sped it up even more, it'd be kind of like having it less on than it would be on the full time, if that makes any sense. So PWM lets us take and create a variable output so that we can effectively fade the LED. It's not really fading. What it's really doing is flicking a light switch really fast, and we can change if it's more on or more off, but it's like flicking a light switch back and forth really quickly. So what we're going to do is we're going to make this light fade. So we're going to get rid of most of the code in the loop. So I'm just going to highlight those 4 lines and delete them. Now, what we're going to do what's called an analog write. And the question is who, that we're going to talk to rledPin. And then how much is a number between 0 and 255. So I'm going to do 100. And we're going to test this. And the light to be on but kind of dim. I'm then going to stop it. And instead of doing 100, I'm going to do 50. 150. 50. It should be dimmer. And if I do 5, it should be barely on. It's not exactly linear, but. And if you notice, my processor, the simulation time has gone way down.
Okay.
Well, that's starting to count in like milliseconds now instead of.
Yep. And that's because it's simulating the PWM wave.
Hey, I'm showing an error on mine where it says analog write.
Did you?
I've got it. I have it worded just like you. Now, does it have to be a capital W?
It does have to be a capital W.
Okay, that's the difference. All right.
Yep, that would be it. So yes, C is case sensitive, so you just have to make sure we follow exactly. What's nice is a lot of the code, as we get more powerful, is going to be copy and paste from ourselves. So once we have it working in chunks, we'll make it better and better. That's why I always run it in small steps, though, because it lets me test to make sure I'm working before we make it more complicated.
Okay, I still have it's still giving me an error. I changed it to analog write, rledPin. I mean, it looks the same as yours. I mean, I still had it on 100. I didn't move it.
What's the error message say?
Let me hit the simulation again. Seems like your code has some errors, is all it says. Okay, in function. It says void loop.
Yep.
1015 error. rledPin was not declared in this scope.
Did you do capital P, or did you match the case of the rledPin you typed earlier?
Oh no, I didn't. Okay, I didn't use. Yeah, the same one is up there. Okay, so.
Yep.
Right.
That's fine. That's completely fine.
Yep. All right.
That was my guess. If we had more code, I would have had you share it. But it's really like with code errors, I'm usually pretty good. And let me simulate that error just so everyone can see what that looks like. What's nice is this is the exact same error console you'll get if you use the Arduino software on a computer to program it. It says in function void loop 10, line 10, column 15. So right here, rledPin was not declared in this scope because rledPin lowercase and rledPin capital are two different words.
That's pretty handy, just being able to tell you exactly where the error happened in the whole code block.
And it's exactly the same debugger you get with the Arduino environment. That's why I really like TinkerCAD. This is just like using Arduino, just slower. But you don't have to buy anything before you start.
Okay, so it looks like I'm good. I just got to change it to 5 from 100.
Excellent. Yep, I was just proving that you can do different values. We're gonna add two new variables, and I tend to keep all my variables up top of my code, and I tend to leave white space between chunks of code, and that makes it easier to read and go back and understand what I did. So we're gonna make two new integers. I'm gonna make one called brightness, and I'm gonna set that to 0. And the spaces here don't matter. The way between the equals, I just try to make it look easier to read. And int change is equal to 1. So now I'm going to change it. So instead of writing 5, I'm going to write brightness. If I ran code now, what would the LED do?
Nothing.
Yeah, absolutely nothing. Because you have an output value of 0 for your pulse width.
Exactly. So because brightness is 0, writing 0 would do nothing. But this code loops. So if I change the value of brightness, then it would automatically, it would write the new value. So we're going to add a new line. We're going to do brightness equals brightness plus change. And I'm going to add a delay of 1 millisecond, a micromillisecond, which should be enough to see it work. If I run this, nope, I need to put a delay of 10. If you run this for a while, you'll notice the light goes up and then falls down to nothing, and then up and then falls down again.
Yeah.
So that's kind of weird. We'll get into why in a moment, but it'd be really nice to know what the value of brightness was at any time, so we could sort of see what the computer is thinking at this time. So we're going to go and add some new features to our code. So I'm going to stop the simulation, and we're going to add a new thing to our setup. We're going to start what's called a serial console. And what we're going to do is capital S Serial.begin, and we're going to do 9600. 9600 is just kind of a magic number. There are common speeds at which you can talk over serial. 9600 happens to be one that works almost always.
That's not cute.
I hear an Amanda in the background.
Yeah, Amanda just came in and the dog's saying hi. And the dog just fell up the stairs. She's very good at that.
Excellent. All right. I'm now going to take, and I'm going to, in my code, before the delay, I'm going to print out the value by using capital S Serial, print, ln, print line, brightness. Now I'm going to run this code, and it's going to be exactly the same, except if I turn up the serial monitor, we should see that number changing over time. It's getting bigger and bigger and bigger and bigger, and then it's going to drop down. But the number's still getting bigger, but the brightness is going down. It went down.
Oh, serial. Oh, okay, there we go. Yeah.
And what's really neat is we can actually see this as a graph. It's a really boring graph because it's just a straight line and then just re-zooming over and over again. But so why the heck is the light going down even though the brightness should be getting higher and higher?
You're over 255.
Which I mentioned earlier was the highest value you could put into analog write. So the way it works is everyone, thankfully I can make this analogy because I said this in class and everyone said, what do you mean odometer? I said the numbers on your car, and they said, I said roll over, and they said, what do you mean roll over? I said, and at that moment I felt old. But if you're a used car salesman and you put a drill in the odometer, you can make it roll to the point where all of a sudden went from 999,000 miles down to 0 miles. At 255, this rolls over. And it's 255 because that happens to be a nice round binary number. 8 bits technically, but that doesn't really matter for you guys. But 255 happens to be a nice round number. It's sort of the computer equivalent of 999. So we're going to take and we're going to make the circuit behave the same way it is, but at least do what we're telling it to. So sort of like when your child or dog does something wrong, but you say, do that thing, and they're like, yeah, see, they're doing it. We're going to take and we're going to tell the program anytime the value gets above 255, that should go back to 0, which is what it's already doing, but we want to actually see that happen. So I've stopped my simulation. Make sure you stop simulation before you try to do stuff. If not what you type, which is very frustrating sometimes. I'm going to put an if statement. So if parenthesis, and I'm going to open swirly bracket, close swirly bracket. I'm sort of building the structure for my code before I put anything in. So open close parenthesis is what the if's going to look at, and inside the swirly brackets is what it's going to do. So we want to say if brightness is greater than 255, brightness equals 0. If I don't have fat fingers, I can write that.
I see an error in your code.
What's that?
Should be 254.
What will happen is when I hit 255, I can write 255 actually.
256.
Oh.
Right.
There
you go.
Thank you.
No worries.
Moment of dumb.
You can do it either way. 254 would work too.
Yeah. This one's more clear because 255 is the magic number we want to think about. And what's nice is actually in class, typically, John, is I would actually let the error happen and then say, oops, it happened because this is not something I've memorized. I don't memorize all this code.
Yeah.
I memorize chunks, and it's easy to make dumb mistakes. And it's very important, especially not for this, but for Sandra, when you're working with kids, if you have a perfectly canned situation where everything works in the first try, that's not realistic. Even John probably makes bonehead errors like that occasionally.
Always. Constantly.
And it's important. A lot of these kids learn from YouTube, and it's really cool, but most YouTube people edit their errors out. And it's important to see that things don't work on the first try, and it's really easy to fix. And we would have seen it. What we would have saw is it would have blinked down. It would look fine because it's not the error. But we'd see the error later, and we'd see it blinking up and down. But let's run that code and actually
you probably
see what
wouldn't
happens.
have noticed it in the actual simulation, right?
I would later, actually. When we start adding the next part of the circuit, we would have made the error. We would have found that error. It would have showed us that error, and it would have made sense. So if we watch our graph, it makes a nice drop, and then it goes up, and then falls off. And this is what's called a sawtooth wave.
Where did this 255 come from again? I guess I missed that. What's this?
It happens to be that 250 is that the PWM output only has 8 bits of precision.
Okay.
So it has 8 ones, and it has a string of 8 ones is the biggest we can get. That is 0, 2, 4, 8, 16, 32, 64, 128. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is 255.
Right.
Well,
yeah, I get you.
My kids, at least the 1 or 2 of my kids, know it because we go over binary before this. And if you've ever played, which again, this goes into things I can't talk about anymore, but the original Legend of Zelda, the maximum number of rupees you could have was 255. And that was because they stored it as an 8-bit digit.
Ah, okay.
Yep. And technically an only positive, so an unsigned 8-bit number. So anyway, we now have the sawtooth working, but we really should have this fade up and then down, then up, then down. So we need to be a little more clever. So we're going to stop the simulation. Instead of brightness equals 0, we're going to take and say change is equal to negative change. So now what's going to happen is our change is going to be here. So we're going to make our print a little nicer so we can see what we're doing. We're going to add a second line, and I'm just going to cheat by copying and pasting because I like copy and paste code. I'm going to do this change. So now we'll see the number, then a 1 or a negative 1. And let's see what happens when we run the simulation. It's not quite right, but we'll see it. Oh, okay, it didn't like that. Okay, we're going to change this a little bit more. Instead of print line, we're going to do print. And then we're going to do serial print. And we're going to do quote, comma, quote. Now it's going to be brightness, comma, change. And that will let the serial console print nicer.
That's not quite what you're going to want.
Oh, thank you. Get rid of the print line also. There we go. So the blue line is our brightness. The red line is our change. And now it's good. Change went to -1. You can't tell really. It just dropped a hair. And now we're going to have a similar problem that we had before, except the opposite direction. So what's wrong with our code now?
Just keeps going down and down and down.
So we need to catch the other direction. And now it actually behaves like a sawtooth, the opposite direction, where it's falling, then jumping up, then falling. So the way we're going to do this is we're going to use an OR statement, and in C, that's 2 of the pipe key that's right above the enter. That's shift the backslash key above enter. And do brightness less than or equal to 0. And I'll start simulation. And
You're missing a letter H in your second brightness.
I'm aware. Remember I said I like copy and paste coding? There's a reason I like copy and paste coding. I have terminally fat fingers. I tend to write dumb mistakes all the time. I said, as I tell my kids, if something runs in the first try, I suspicious of it from the beginning because I assume something else is terribly wrong.
Yeah, I don't know how many times it's taken me 45 minutes to find like one semicolon or lack thereof.
Oh, it gets worse when you program in Python where it doesn't require semicolons, so you get used to it, and then you try to do it the other way. And getting Python in my C causes no bounds of errors. C in my Python's not nearly as bad deal. It's a lot more tolerant to those things. So now we have a nicely happy fading LED. It goes up and it goes down. It goes up and goes down.
Mine's going straight. I don't know where I missed something.
Do you have the... Okay, so I'm going to make sure the entire loop function is available. Do you have the brightness equals brightness plus change?
Brightness equals brightness plus change. Yep.
Is your change equal to 1?
Oh, wait, see. Okay.
That would do it.
Okay, where am I? Let's see.
Up top.
Yep. Okay. Oh, wait. Oh, well, okay. Okay. So
Right.
change equals 1, 0. I have those.
Oh, you do? Okay.
Yeah.
Okay, let me see your screen. Let's take a look at it. Is it still being shared or?
All right, here we go. Entire screen, share now. Boom. 1. Okay, should see it now.
Okay. Okay. Oh, I see it. On line 15.
Yep.
You need to change the 5 to brightness.
Okay, where's this 5? Make it brightness.
Yep. We replaced the static number with a variable so we could change it over time.
Yeah. I think you're
That's
just
fine.
going a little fast for this idiot that I am.
No. Then tell me to slow down. I'm more than happy to, make sure we're working with stuff. And it is.
That's pretty funkin'. Is this what other people had?
No. Let me take a look. Oh, okay. So brightness, if analog is okay, brightness is equal to change. Okay, that's good. Scroll down. I need to see.
Yeah.
Okay, the first thing is on line 22. Let's get rid of the ln.
Okay. Oh yeah.
Oh, I see it, and I see the other problem. And it is you need to change the direction on the brightness on line 18. On the 4th to last character over on the right hand side. More right, all the way right. Make that the other. Make it less than or equal to 0.
Okay, less than or equal to 0. Say that again.
You need to change the greater than. The
greater. Okay, the greater than. Okay, yeah, I got you.
The downside of copy paste coding.
Yeah.
Start submission, and we now should have a happy.
Okay, let's see. Boink.
Looks good.
And boom, back down. Yep.
Okay, that look all right?
That looks great.
Okay, I'll stop that and I think that's it. I'm not. I think I'm not typing as fast as you. So
okay, yeah.
I think you move on to the next thing while I'm still typing.
Okay, just if you need me to hold up for a second, just say hold up for a moment. I can.
Okay, I'm trying not to be the one that drags everyone down, but.
I said there's 5 of us. It's not. There's 5 of you. You know, it's not the end of the world if it slow down for a moment.
Okay, so back to you presenting then.
Yep.
Okay. Yep.
I am. Okay.
There we go.
And I said, so think of it this way: if you stop me for 2 seconds to slow down, that's gonna be a lot less time than having to debug and figure out why you did something wrong. Although it is valuable to see common errors, so it's not the end of the world. I don't even think of helping a student with a problem wasting time, because everyone's seeing types of mistakes that can happen because they're really easy to make. Mm-hmm. So the last thing we're going to do is we're going to change the change from 1 to 5. Now we need to add one more change here, because unfortunately our code here assumed that we only ever go up by 1. We're just going to take and copy line 16 and paste it also on line 20. This means we won't hit the actual peaks ever, which is okay, but it'll keep us in bounds and it'll look better. And this will make it be more important for our next the next thing we do, which is going to be make pretty rainbow colors.
Okay, so the only thing we changed at the top was where it said int change. We changed that from 1 to 5, right?
Yep. And then we copied line 16.
Yep, which I did.
And pasted it inside just below after the change. After we changed the change.
Yep.
And now it should do. You should see the red line be more defined, and the fade should be happening quite a bit quicker. And the zigzag wave should be more.
Yeah. I'm looking like yours.
Different scale on yours, because I mean mine is like peaking at 250. Oh, it's doing exactly what it should do, I guess.
Yeah, it's.
Yeah,
I have my screen zoomed in some, Chris, so that it's easier to read my code. Because between the video conferencing, minus and equals start looking real similar.
Yeah.
And now, if we put any number in for change, as long as it's bigger than I wouldn't go bigger than 50, but it should work still happily. Oh, if my code actually ran now. Come on, we can do it. Okay, there we go. Now it shoots up and down really quick. So now we can make this way more interesting, because a single red LED is cute, but doesn't really, it's a blinky light, which is good. But the standard LED is kind of boring. My favorite LED is the RGB LED. So we're going to take and hide the code panel. And we're going to delete our LED. And we're going to delete our resistor. And I'm going to delete the blue wire for good measure too. Just clear out all the wires. And that's cool.
Hope you freeze.
And I'm going to drag this LED
over
above the gutter. Yep.
I can hear you all right, Bill, but he's kind of cutting in and out.
Oh, what was that? Sorry about that.
Yeah, Chris, you're kind of in and out, and your screen froze for a second.
Oh, now you're back.
Okay.
Is it out? Okay. Right, so I just got to see what was it. Where was the thing that I was grabbing there?
I'm going to delete that.
Yeah.
Okay, so I'm going to scroll down, and I'm looking for RGB LED. It's about halfway down.
Okay, yep, I got it.
And I'm going to drag that guy over and put him above the gutter.
Okay.
Now, if we mouse over, we see this LED is stupid and backwards and broken. I don't like it, but we'll have to deal with it because it's what we have. So the pin 1 is red. Pin 2 is cathode. Pin 3 is blue for some asinine reason. And pin 4 is green. I don't know why they have it that way, but it's how it is. So first thing we're going to do is we're going to connect the cathode pin to the ground. And I'm going to do that by running a wire from the same row down to the negative rail. I'm going to make that wire black. I'm then going to drag a resistor to the red pin across the gutter.
Keep freezing up.
Yeah, you're freezing up, Chris, if you can hear us. Too many people streaming.
Mm. Kind of funny in the
blue
backwoods.
pin.
Oh. Chris, you froze up quite a bit, so we're probably behind you now. Oh yeah, big time.
Yeah, way behind you.
Okay.
Yeah, you froze up for like a minute and a half there.
Yeah.
Oh, okay. Let me go and figure out what the heck is running in the background. Exit that. What things don't I need running? What is taking?
My Google Chrome absolutely just kills my CPU. I mean, it's a horrible.
Same with Vivaldi. So I'm just trying to figure out where I can close stuff that I don't need. So I'm going to close all these tabs. I'm going to close this tab. 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 All right. Let's see if that's better. All right. So I just dragged LEDs to the red, blue, and green pins. And then I'm running
resistors, you mean?
I'm putting resistors. I could put a single resistor on a cathode, Rich. The reason I don't do that is because technically on RGB LEDs, these have to be different values. On TinkerCAD, it's less picky about it, but on real ones, you technically want to use half the resistance on the red that you use on the blues, or the other vice versa. I can always have to look it up every time. But on TinkerCAD, we can get away without it. So I'm running a wire from the red resistor now to pin 11. I'm going to make that wire orange. I'm going to run a wire from the blue wire resistor to 10. I'm going to make that wire blue. And I'm going to wire from the third resistor, the green resistor, to 9 and leave that green.
Blue resistor to 10.
Oh, stupid.
Now, when we do our code, we're always going to do RGB, not RBG, because our red, green, blue is the typical way you do colors. I don't know why this LED is wired wrong, but whoever designed it in TinkerCAD has it worked it because it probably break other circuits they change.
Yeah, you're still kind of skipping a bit.
Yeah.
All right, what else can I close? All right, I'm going to move this tab to its new window, and then I'm going to just close the window, this whole window here. Okay, close that entire window. That should help. Is there any background services?
Amazon running in your background.
Well, that's the question. Is there?
You sound good now. Don't know. Maybe you got it.
How do I? Okay, whatever. All right. So, all I was saying is that we're gonna, whenever we write code, we're gonna do everything based on red, green, blue, not red, blue, green. So we're gonna fix that once up front, and then the rest of the code, I'm always gonna do it red, green, blue. So we need to go to our code, and we need to change our code quite a bit. So the first thing we're gonna do is we're going to take where it says in LED pin, we're going to make that R LED pin. And we're going to change this number to 11. And I'm going to copy that entire line of code and paste it 2 more times. And then we're going to go
Do 10, 9.
G, B. And I'm going to do
I don't know.
9, then 10.
9 and 10, yep.
Be aware that their LED is weird and has the stupid blue in the wrong order. So we're going to fix that. This will be out of order, but for the rest of the time, it'll be RGB every time we talk about them. So before we do anything else, we're going to change. We're going to now go to line 10, and we're going to copy and paste that 2 more times. But we're going to make it RGB.
What's it up? All right. Void setup. pinMode. Oh, okay.
I'm also going to make my change back to like 10. It's not super high. So I'm changing the change back down to like 10, so it's not crazy high number.
All right. So.
All right. Let's see.
So output out. Okay. So.
Okay. RGB. Okay, I got you.
Oh, not capital. Why was that capital?
G.
And now, before we go any further, we're just going to echo to analog rate, and we're going to make it rledPin, and we're going to start the simulation, and the LED should turn red. Once we know it's working, we'll stop simulation.
Oh, I got a bunch of code errors.
Okay, that's fine.
Okay, let's see. It says redefinition of. Is it error redefinition of int rledPin?
Did you change the G up top? Did you change this to G and this to B?
Oh, you know what? Okay, I guess I didn't do that yet. All right, let me get off the close here.
No worries.
Okay, so
I'm not gonna error on 19.
G.
What's the error? What's it say?
In function void loop. LED pin was declared in the scope. Oh, so
that you change that to rledPin.
Yep, I got it.
Okay, I think I just had the same error. So
go to line 19 and
19?
change that to where it's analog rate. Make that rledPin.
Yep.
Okay, I don't have that in line 19. I have that in 17.
That's fine. It's just because you probably didn't.
Okay, so I make that an R. Okay, so I make that an R.
Yep.
Am I copying it twice or no?
No, just once. We're just going to do it
Just
once.
Okay, so I changed that to an R. And it says void loop 1723 error brightness was not declared in this scope.
Did you make an R? Did you make rbrightness already?
Maybe I didn't. Let me see. Let me close this. All right, so where is rLED? All right, so where am I supposed to make it rbrightness?
I didn't make rbrightness. I left brightness by itself.
Okay, yep.
And then this should be the same because we didn't change that from before, so that shouldn't have broken anything because this was this. Did you forget a semicolon somewhere?
Oh, wait a second. I think I just. All right, just back up a little bit. What line was the first thing?
Okay,
Right,
so
I
on line
apologize.
5, it's okay.
Yep, line 5.
Do you have brightness? Just brightness here.
Wait a sec. I don't think I have that line. Let me see.
That would do it.
All right, so let's see. So 5 int brightness equals 0. All right, let's see.
Yep.
All right. I think it's working now. Yeah, no errors. So
is the light turning on red?
I can't see it at the moment. My screen has gotten larger. There's something on the right-hand side of the screen under Arduino. It says how it works.
Oh, okay.
And that's pushed the code across further.
I know it's wrong. All right, so here's what I'm going to do. I'm going to hand you. Copy. In the chat, I'm pasting a link for you.
Okay.
You're going to click on that link.
Yep.
And
Okay.
you're going to tinker this thing.
Okay. Now this is. I just clicked on it and it said this requested page is expired.
Oh, hold on. Try it now. Try the new link. I put a new one in. Did that work?
Probably just invited him to a new meeting that no one else is in.
No. It's just all it is just that I basically took the TinkerCAD circuit and shared the TinkerCAD circuit.
Yeah.
So that he should be able to start off where I am without.
Right.
But I don't know if it worked because you got a weird expired thing.
Is he even still on?
I'm not sure.
It says 6.
It worked when I clicked on it. No, he is gone. He has disappeared.
Yep.
All right. He'll be back in a moment once he gets going. We are just going to test the other two colors by changing line G. And now the light should glow green. And then B. I don't know where Bill went.
Mm-hmm.
Is it flipped, the green and blue flipped, Chris?
Well, I got the green to work. I put in B and it didn't work.
What's the error message say?
19.2 was not declared in the scope.
Double check your spelling on line 3.
bledPin.
Yeah.
Equals 10.
Is the case the same?
Yep.
I would take and just copy the text from the variable name and then double click and then paste and cover it. Because maybe you have maybe it says BGLED or something stupid like that. Let's see if that fixes it.
Oh, hold on. Oh, no, I just deleted the G and didn't put the B in. That
would do it.
Yep, working fine now.
Excellent. So the reason we did that before doing anything else is just to make sure that we had everything wired up right and that we had the green and blue flipped properly because, again, they're weird and there. So now we're going to start making this a little more powerful. We're going to go and add in. We're going to copy the analog rate, line 19. And then we're going to paste that 2 more times.
Under the void loop? Yeah, okay.
Yep. And we're going to make it R, then G. So I'll wait a moment for you guys to catch up. But all I did was this section here, and I don't know where Bill went.
Can he get back in without another invite?
He can if he has the link, but I don't know if he has the link anymore.
Yeah.
You can post it to him in Slack. That might help.
I will do that right now.
Or, yeah, you're in the Slack, right?
Yep.
Okay. Yeah, he's got a, he's in there, so you can send it. I am too.
I will do that right now.
Then he appears to have it up, so that might be a good sign.
I'll bring it up and do that right now. I'm guessing he clicked and it replaced the meet with the TinkerCAD.
That's probably what happened. Now he couldn't get back to it and just like,
Come on. You can do it, Slack. Well, good news is that we have a recording too, so this will be available for people to see. Oh my God, Slack, just open.
What are you trying to get into? Oh, now you're frozen.
Yeah, he's opening Slack up to send Bill the link in case he starts looking around for it. That'll give him a prompt, and he can then get back in maybe.
What's Slack or Flack or
Yeah.
what?
Slack. It's basically a chat program, right? We use it for the makerspace. Think about Microsoft Team or it's
Right.
it's got channels and people, right? And you just kind of text each other.
If you use Discord.
Yeah, Discord.
Discord. There you go. I was trying to think of another one that somebody might have used. I'm like, I can't think of any.
Oh, okay.
It's professional Discord.
Okay.
So what's the Yakabadi or something like that?
Yeah.
And well, I just sent him a link to the meet, and then I'm also going to send him a separate link to my TinkerCAD. So share, invite people, nope. Copy, nope. And then paste my circuit.
Oh, there he is.
Hey, Bill. Sorry about that, Bill. I think the meet got closed. In Slack, I gave you a link to the circuit, and that one should work. Let me double check it myself.
Why is Concord Internet so slow?
Yeah. I don't know. Usually it's fine. It's good until during the school day. It's perfect. So I guess I've had problems with night school before. So maybe everyone gets online. Maybe everyone gets home. Oh, shift gets off at the hospital and everyone gets online. So we live right near the hospital. So probably a lot of people got off for the working day, like administration people at the hospital got off and went online to work from home. And what?
No, I was gonna say, you on a fiber network or no?
I missed that.
Are you on a fiber network?
I'm on cable. I don't know. I have Xfinity. I'm on their higher 200 megabit plan.
Okay.
So it should be sufficiently fast, but
bandwidth is guaranteed, not lag.
I know. Well, bandwidth is peak also. So if we run this circuit with the red, green, and blue all turned on, the light's going to blink white instead of any particular color. And that's because when you're using additive colors like LEDs, the mixture of red, green, and blue produces white. But now we can do some more interesting things with this because we can take and make it so our brightnesses aren't all the same value. Bill, were you able to click on that link?
Might have to go in settings and turn your mic and stuff back on.
Oh, yeah, can you hear me now?
There you go.
Okay, yeah. No, I've determined at this point I'm just going to watch you guys on your screen because otherwise I'll just be catching up all the time.
All right. I'll have the video available, and I can also the link if you circuit. And I can get it, but that's fine.
Okay.
All right. So we now have a light that blinks white. But what's really cool is if it fades through different colors. So what we're going to do is we're going to change brightness Can I type? To rbrightness and rchange. And I'm going to copy those and paste them 3 times. And then I'm going to go and change the first one to gbrightness and gchange, and bbrightness and bchange. And most importantly, I'm going to change the values under gchange to some other number. I'm going to do 7 and 3.
And 10 and 3. Okay.
Now we have to recopy a big chunk of our code. So now I'm going to copy line 26, and I'm going to move it a little bit so I'm going to add a line here, and I'm going to make this rbrightness plus rbrightness plus rchange. Then copy that line, paste it, bbrightness plus bbrightness, not
R,
plus
need your R for
bchange.
brightness.
Oh, thank you.
Yeah, right there. You need your R in the brightness.
Yep.
There you go.
Thank you very much. B,
All right. So R,
B,
R,
and B.
R.
We could use a plus equals operator here, but I did it this way because it's a little more clear for people who aren't as comfortable with programming.
So R, G, G.
Yeah, I found a lot of issues with the internet. I've tried to edit a video that was using an online, it was a Premiere Rush, and I couldn't even use it. It was just locking up.
Yeah. You know, this has definitely shown how important internet, good, consistent, fast internet is.
Yeah.
Mm-hmm.
All right. And now I need to edit my block of code between 31 and 34. So rbrightness, rchange, rchange, rbrightness, rbrightness, rchange, and then we're going to copy that whole block of code. And make it, I'm going to hide my serial monitor. G, 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 M, B,
Oh, and you're doing the
B,
print.
B,
Don't forget the squirrely.
B, Ooh, then I have an error message. Cut that.
All right, so okay, speed change, we got that there, and you got all those values the same. GB, okay. And let's see where I get analog rate rledPin.
All right, and then finally, I'm going to take lines 46 and 47. I'm going to put an R in front of rbrightness on 46. I'm going to copy and paste those 2 lines. And we're going to go G and B.
So
Actually, type great letter when I say the. All right, so what's the error message?
23.
And what does it say?
Brightness was not declared in the
Oh.
scope. Oh, yeah.
Yep.
Like
Thank
RGB.
you. I made the same error.
Yeah.
Again, it's so easy to make silly errors. So, and now, I have an error message on line 52. Oh, I'm gonna get rid of the Okay. Oh.
R
Okay.
brightness integer. R brightness.
I'm gonna make that. I'm gonna line. I have a line on rchange. What's your error message say?
Oh, excuse me. Well, actually, let's close that and try again here.
All right, I'm gonna close. I'm gonna delete lines. We're gonna have an error message on line 52 right now. So I'm gonna take and I'm gonna delete. I'm gonna delete lines 51 and 52. I'm gonna make the last print on line 50 a print line. I'm gonna start simulation, and I'm gonna help you guys get your stuff working once mine's going, just so you can see the pretty colors. All right. So if you're having problems, Chris, do you want to take and share your screen? I can take a look at it.
Yeah.
So you go to the meet and you click on the white bar on the bottom and click present, and then you have to tell which monitor.
Sorry. Yeah. All right. So click on the bottom. Let's see, settings. Oh, do I click on you? You're okay. Yeah.
And it has a big thing with a thumbnail of your screen. Click on the screen and then hit share again.
Yeah. Okay. So we want to do screen one share. Okay, there we go.
Excellent. Okay. And I'm going to begin the screen.
See, I haven't really screwed with anything down here though,
okay.
so the serial print, I know.
That's fine. That's fine. And okay, I move my mouse. Hit start simulation again. Because there are line. Oh, go to 46. Go down to 46. So that needs to be rbrightness.
Mm-hmm.
And we're gonna get rid of line 48. Delete line 48. And just delete. And we're gonna copy and paste lines 46 and 47.
So I just wasn't far enough ahead then.
Yep, that's fine. That's good. Enter, paste. And get rid of line 51. Okay.
Get rid of line 51?
Yep. We don't need him anymore.
Okay. So
make that G. Yep. And then also make the line 50 a print line. Just add ln to the end of the print.
Print ln.
Yep. And then hit start, and we should see pretty lights. Yeah. Now open the serial monitor, and you should see some really cool wavy, like, all the graph sorts of cool colors.
Yeah.
And it's like a rainbow.
Very neat.
And this is
I have the same problem with the orange line that you have, so I just thought that was interesting. Must be a glitch.
It doesn't go away. It is.
Yep.
Sometimes it happens, sometimes it doesn't.
Well, it didn't show up in the error, down the box.
Yeah, but it makes it hard when you get another error, because then you don't know which line to look at. I actually have 3 of them on my screen, which is really annoying.
Yeah, again, it's one of those things where, for what I'm paying for, it doesn't even have ads. So, like, for what I'm paying for it, I'm not even paying with ads.
Yeah, and I'm not the debugger. I'm going to be interested to look at that, because that's something that might make it a little bit, worth trying something if you're doing something a little complicated.
Yeah, and the debugger is the same serial debugger you get on Arduino if you just use the Arduino C software. So the skill that you learned here goes directly onto a wiring board. If you you could make this is 100% a nice analog for what you do if you actually built one on a breadboard.
Yeah, as long as you're only, I think you can only do one dock though, right? So if you wanted to do, a class or bring in something else, you have to have you only get one document, right?
You'd have to copy and paste it on top of the document. So you could bring classes in.
It's just all one document. Sure, I understand.
But you can import library. It does have a full library importation tool. So if you could upload as a library, it might work because I like the liquid crystal. You could just bring in stuff like that. So.
Oh, okay. So you can pull in stuff off of GitHub or whatever.
Yeah,
okay.
I don't know if it's GitHub. I don't know if they come in for GitHub or if they just are stuff they've already included. But they have a servo library. They have a servo library. They have the liquid crystal library in there.
Yeah. Okay.
But it's a good place to get started, and the overhead is very little besides the network. So I hope that was good for you guys. I hope you enjoyed it and found it useful.
Yeah.
Sorry that we had some technical issues.
It's just there's a lot of like having to sit down and actually do this over and over again to be able to make anything of it aside from link.
Well, the thing is, if you have like my big favorite thing right now is I have discovered and fell in love with the M5 Stick C. This is $11 off DigiKey.
You want to go in present mode because your video quality is horrible on this.
Okay, let me go and settings.
Yeah, because it looks like you're still sharing your screen out.
Yeah, there we go. I will stop presenting. So, I have the wrong camera. Hold on. I have a depth camera. Yeah, you want the RGB version. Sorry. So Chris, I can do 3D scanning.
Really?
I have the Intel RealSense depth camera. It's like a Kinect. But anyway, this thing is a small ESP-based device that has a battery, USB-C, Wi-Fi, Bluetooth, a screen, and it's programmed in a block language or Python. And it's $11. So building projects with it.
Yeah, there's some neat stuff on there.
It has an IR blaster. So one of the projects I've been working on is making a TV remote.
Yeah, you're cutting in and out.
It controls my phone, so I can turn on the TV and change the volume stick remote. Because once the TV is on, I can change everything with my phone using the Kindle Fire app. But I can't turn the TV on or change the volume. But this has an IR blaster in it, so I can make it act like a TV remote, and it hosts a web page, so I can go on my phone and just like go to its web page and like change the volume on my TV.
That's yeah. Well, I just have Samsung phone and a Samsung TV, and I can just use that. So.
Well, yeah, I don't have that. But
it's more fun his way.
Yes, I know. It's complicated as hell, but more fun.
Yeah. So wait, with your thing, could you change your neighbor's TV channel?
Ooh.
No, because line of sight. But I was telling because I set these out to my kids for my robotics class, so they have some hardware to play with for the end of the school year, so they can actually play with stuff. And I was saying conceptually, they could make an app that would just turn off any TV pointed at, like a TVBegin. And then I told them, but as at least one student has seen, having your projector turned off on you while you're teaching infuriates the teacher. And if I hear about it, I'll know who I hand out devices that are capable of such things.
It's kind of like that grumpy old men where his neighbor's in the back room or, in the back window, just changing the channel from the other house.
Nice. Yeah.
All right. So thank you very much, guys. I hope this was good for you guys and you enjoyed it. Sorry we had some technical glitches, but I think we overcame.
Yeah.
Well, yeah, we certainly did. Thank you, Chris.
Yeah, I appreciate it. This will get me started on that. So give me a head start.
You guys, I'm on the Slack, so if you're in the thing, if you have questions, I'm always happy to help and show you guys stuff. And Chris, obviously, you have my contact, whatever.
Yeah.
And Rich, obviously, you have my contact too. All right. Thank you very much.
Really appreciate it.
All right, thanks.
Bye.
Bye, everybody.
Bye-bye.
Yeah.